necessarily boil. The heated or vaporized fluid exits the boiler for use in various processes or heating applications. 1, 2, including water heating, central heating, boiler-based power generation, cooking, and sanitation. Contents. Heat sources. Materials. Energy. Boiler efficiency input-output method, or direct method. Heat loss method, or indirect method. Configurations. Safety. Superheated steam boiler, supercritical steam generator. Accessories, boiler fittings and accessories. Steam accessories. Combustion accessories. Other essential items. Draft. See also. References. Further reading. Heat sources. In a fossil fuel power plant using a steam cycle for power generation, the primary heat source will be combustion of coal, oil, or natural gas. In some cases, byproduct fuels such as the carbon monoxide-rich of gases of a coke battery can be burned to heat a boiler. Biofuels such as bagasse, where economically available, can also be used. In a nuclear power plant, boilers called steam generators are heated by the heat produced by nuclear fission. Where a large volume of hot gas is available from some process, a heat recovery steam generator or recovery boiler can use the heat to produce steam, with little or no extra fuel consumed. Such a configuration is common in a combined cycle power plant where a gas turbine and a steam boiler are used. In all cases, the combustion product waste gases are separate from the working fluid of the steam cycle, making these systems examples of external combustion engines. Materials. The pressure vessel of a boiler is usually made of steel, or alloy steel, or historically of wrought iron. Stainless steel, especially of the austenitic types, is not used in wetted parts of boilers due to corrosion and stress corrosion cracking. 3. However, ferritic stainless steel is often used in superheater sections that will not be exposed to boiling water, and electrically heated stainless steel shell boilers are allowed under the European Pressure Equipment Directive for production of steam for sterilizers and disinfectors. 4. In live steam models, copper or brass is often used because it is more easily fabricated in smaller size boilers. Historically, copper was often used for fireboxes, particularly for steam locomotives, because of its better formability and higher thermal conductivity. However, in more recent times, the high price of copper often makes this an uneconomic choice, and cheaper substitutes, such as steel, are used instead. For much of the Victorian age of steam, the only material used for boiler making was the highest grade of wrought iron, with assembly by riveting. This iron was often obtained from specialist iron works, such as those in the Cleetham, UK, area, noted for the high quality of their rolled plate, which was especially suitable for use in critical applications such as high-pressure boilers. In the 20th century, design practice moved towards the use of steel, with welded construction, which is stronger and cheaper, and can be fabricated more quickly and with less labor. Wrought iron boilers corrode far more slowly than their modern-day steel counterparts, and are less susceptible to localized pitting and stress corrosion. That makes longevity of older wrought iron boilers far superior to that of welded steel boilers. Cast iron may be used for the heating vessel of domestic water heaters. Although such heaters are usually termed boilers in some countries, their purpose is usually to produce hot water, not steam, and so they run at low pressure and try to avoid boiling. The brittleness of cast iron makes it impractical for high-pressure steam boilers. Energy. The source of heat for a boiler is combustion of any of several fuels, such as wood, coal, oil, or natural gas. Electric steam boilers use resistance or immersion-type heating elements. Nuclear fission is also used as a heat source for generating steam, either directly, BWR, or, in most cases, in specialized heat exchanger scaled steam generators, PWR. Heat recovery steam generators, HRSGs, use the heat rejected from of the processes such as gas turbine. Boiler efficiency. There are two methods to measure the boiler efficiency in the ESM Performance Test Code, PTC, for boilers ESM PTC 4, 5, and for HRSG ESM PTC 4.4 and EN 12952-15, 6, 7, for water tube boilers 1. Input-output method, direct method. 2. Heat loss method, indirect method. Input-output method, or direct method. Direct method of boiler efficiency test is more usable or more common. Boiler efficiency equals power out / power in equals Q, HGHF, / QGCV, 100% where Q, rate of steam flow in kilogram / HHG, enthalpy of saturated steam in kg / kilogram HF. Enthalpy of feed water in kg / kgq, rate of fuel use in kilogram / HGCV, gross calorific value in kg / kilogram, for example, pet coke 8200 kg / kilogram, heat loss method, or indirect method. To measure the boiler efficiency in indirect method, parameters like these are needed: ultimate analysis of fuel, H2, S2, S, C, moisture constraint, ash constraint, percentage of O2 or CO2 at flue gas temperature at outlet, ambient temperature in degrees C and humidity of air in kilogram / kilogram, GCV of fuel in kg / kilogram, ash percentage in combustible fuel, GCV of ash in kg / kilogram. Configurations. Boilers can be classified into the following configurations: pot boiler or haycock boiler / haystack boiler, a primitive kettle where a fire heats a partially filled water container from below. 18th century haycock boilers generally produced and stored large volumes of very low pressure steam, often hardly above that of the atmosphere. These could burn wood almost often, coal. Efficiency was very low. Flued boiler with one or two large flues, an early type or forerunner of fire tube boiler. Diagram of a fire tube boiler. Fire tube boiler here. Water partially fills a boiler barrel with a small volume left above to accommodate the steam space. This is the type of boiler used in nearly all steam locomotives. The heat source is inside a furnace or firebox that has to be kept permanently surrounded by the water in order to maintain the temperature of the heating surface below the boiling point. The furnace can be situated at one end of a fire tube, which lengthens the path of the hot gases, thus augmenting the heating surface, which can be further increased by making the gases reverse direction through a second parallel tube or a bundle of multiple tubes. 2-pass or return flue boiler. Alternatively, the gases may be taken along the sides and then beneath boiler through flues. 3-pass boiler. In case of a locomotive type boiler, a boiler barrel extends from the firebox and the hot gases pass through a bundle of fire tubes inside the barrel, which greatly increases the heating surface compared to a single tube and further improves heat transfer. Fire tube boilers usually have a comparatively low rate of steam production, but high steam storage capacity. Fire tube boilers mostly burn solid fuels, but are readily adaptable to those of the liquid or gas variety. Fire tube boilers may also be referred to as Scotch marine or marine type boilers. 8. Diagram of a water tube boiler. Water tube boiler. In this type, tubes filled with water are arranged inside a furnace in a number of possible configurations. Often water tubes connect large drums, the lower one containing water and the upper one steam and water. In other cases, such as a monotube boiler, water is circulated by a pump through a succession of coils. This type generally gives high steam production rates but less storage capacity than the above. Water tube boilers can be designed to exploit any heat source and are generally preferred in high-pressure applications since the high-pressure water /steam is contained within small diameter pipes which can withstand the pressure with a thinner wall. These boilers are commonly constructed in place, roughly square in shape, and can be multiple stories tall. 8. Flash boiler. A flash boiler is a specialized type of water tube boiler in which tubes are close together and water is pumped through them. A flash boiler differs from the type of monotube steam generator in which the tube is permanently filled with water. In a flash boiler, the tube is kept so hot that the water feed is quickly flashed into steam and superheated. Flash boilers had some use in automobiles in the 19th century and this use continued into the early 20th century. 1950s design steam locomotive boiler, from a Victorian Railways glass fire tube boiler with water tube firebox. Sometimes the two above types have been combined in the following manner. The firebox contains an assembly of water tubes, called thermic siphons. The gases then passed through a conventional fire tube boiler. Water tube fireboxes were installed in many Hungarian locomotives, but have met with little success in other countries. Sectional boiler. In a cast iron sectional boiler, sometimes called a pork chop boiler, the water safety.
Okay, now I did it mistake. I was sleepy and click. So now the auto read stop. So we have to read page by page. Sorry for that, but I'm old man. I start to get tired. I'm laying in my bed.
Solid fuels, but are readily adaptable to those of the liquid or gas variety. Fire tube boilers may also be referred to as Scotch marine or marine type boilers. 8. Diagram of a water tube boiler. Water tube boiler. In this type, tubes filled with water are arranged inside a furnace in a number of possible configurations. Often water tubes connect large drums, the lower one containing water and the upper one steam and water. In other cases, such as a monotube boiler, water is circulated by a pump through a succession of coils. This type generally gives high steam production rates but less storage capacity than the above. Water tube boilers can be designed to exploit any heat source and are generally preferred in high-pressure applications since the high-pressure water /steam is contained within small diameter pipes which can withstand the pressure with a thinner wall. These boilers are commonly constructed in place, roughly square in shape, and can be multiple stories tall. 8. Flash boiler. A flash boiler is a specialized type of water tube boiler in which tubes are close together and water is pumped through them. A flash boiler differs from the type of monotube steam generator in which the tube is permanently filled with water. In a flash boiler, the tube is kept so hot that the water feed is quickly flashed into steam and superheated. Flash boilers had some use in automobiles in the 19th century and this use continued into the early 20th century. 1950s design steam locomotive boiler, from a Victorian Railways glass fire tube boiler with water tube firebox. Sometimes the two above types have been combined in the following manner. The firebox contains an assembly of water tubes, called thermic siphons. The gases then pass through a conventional fire tube boiler. Water tube fireboxes were installed in many Hungarian locomotives, but have met with little success in other countries. Sectional boiler. In a cast iron sectional boiler, sometimes called a pork chop boiler, the water is contained inside cast iron sections. These sections are assembled on site to create the finished boiler. Safety. To define and secure boilers safely, some professional specialized organizations such as the American Society of Mechanical Engineers, ASME, develop standards and regulation codes. For instance, The ASME Boiler and Pressure Vessel Code is a standard providing a wide range of rules and directives to ensure compliance of the boilers and other pressure vessels with safety, security and design standards. 9. Historically, boilers were a source of many serious injuries and property destruction due to poorly understood engineering principles. Thin and brittle metal shells can rupture, while poorly welded or riveted seams could open up, leading to a violent eruption of the pressurized steam. When water is converted to steam, it expands to over 1,000 times its original volume and travels down steam pipes at over 100 kilometers per hour, 62 miles per hour. Because of this, steam is an efficient method of moving energy and heat. Around a site from a central boiler house to where it is needed, but without the right boiler feed water treatment, a steam raising plant will suffer from scale formation and corrosion. At best, this increases energy costs and can lead to poor quality steam, reduced efficiency, shorter plant life and unreliable operation. At worst, it can lead to catastrophic failure and loss of life. Collapsed or dislodged boiler tubes can also spray scalding hot steam and smoke out of the air intake and firing chute, injuring the fireman who load the coal into the fire chamber. Extremely large boilers providing hundreds of horsepower to operate factories can potentially demolish entire buildings. 10. A boiler that has a loss of feed water and is permitted to boil dry can be extremely dangerous. If feed water is then sent into the empty boiler, the small cascade of incoming water instantly boils on contact with the superheated metal shell and leads to a violent explosion that cannot be controlled even by safety steam valves. Draining of the boiler can also happen if a leak occurs in the steam supply lines that is larger than the make-up water supply could replace. The Hartford loop was invented in 1919 by the Hartford Steam Boiler Inspection and Insurance Company as a method to help prevent this condition from occurring, and thereby reduce their insurance claims. 11. 12. Superheated steam boiler. A superheated boiler on a steam locomotive. When water is boiled, the result is saturated steam, also referred to as wet steam. Saturated steam, while mostly consisting of water vapor, carries some unevaporated water in the form of droplets. Saturated steam is useful for many purposes, such as cooking, heating and sanitation, but is not desirable when steam is expected to convey energy to machinery, such as a ship's propulsion system or the motion of a steam locomotive. This is because unavoidably temperature and forward/or pressure loss that occurs as steam travels from the boiler to the machinery will cause some condensation, resulting in liquid water being carried into the machinery. The water entrained in the steam may damage a turbine blades or, in the case of a reciprocating steam engine, may cause serious mechanical damage due to hydrostatic lock. Superheated steam boilers evaporate the water and then further heat the steam in a superheater, causing the discharged steam temperature to be substantially above the boiling temperature at the boiler's operating pressure. As the resulting dry steam is much hotter than needed to stay in the vaporous state, it will not contain any significant unevaporated water. Also, higher steam pressure will be possible than with saturated steam, enabling the steam to carry more energy. Although superheating adds more energy to the steam in the form of heat, there is no effect on pressure, which is determined by the rate at which steam is drawn from the boiler and the pressure settings of the safety valves. 13. The fuel consumption required to generate superheated steam is greater than that required to generate an equivalent volume of saturated steam. However, the overall energy efficiency of the steam plant, the combination of boiler, superheater, piping and machinery, generally, will be improved enough to more than offset the increased fuel consumption. Superheater operation is similar to that of the coils on an air conditioning unit, although for a different purpose. The steam piping is directed through the flue gas path in the boiler furnace, an area in which the temperature is typically between 1300 and 1600 degrees Celsius, 2372 and 2912 degrees Fahrenheit. Some superheaters are radiant type, which as the name suggests, they absorb heat by radiation. Others are convection type, absorbing